Okay, class. So we go to example 2, still on Z parameters. Okay. So for these circuits, okay, once again we have to obtain the Z parameters of the network below. Okay. So the given answer is your Z11 is equal to 4 ohms. Okay. So Z12 is 1 ohm. Z21 is 1 ohm. And Z22 is 1.667 ohms. Okay. So we see on the solution. Okay. You just follow the similar step as previous. Okay, so we have to obtain the Z11, Z12 by connect the V1, okay, or your current I1 to port 1, and you open circuit your output port, or your I2 is becomes 0. Okay, so if you look here, okay, from this given circuit, okay, so this is the question, right? So when you open circuit your I2, okay, so you open circuit your I2, so your, okay, you give your V1, okay, your V1 as a voltage source at your input port, okay, so this become your I1, okay, and then this is your I2 is equal to 0. So what you have here is I0. So please avoid to use your I2 because your I2 now is equal to 0. Okay, and then from here, when your I2 is equal to 0, so what you have is only, okay, Z11 which is equal to V1 divided by I1, okay, and your Z21 which is equal to V2 divided by I1, okay, when your I2 is equal to 0. So your Z11, okay, so your Z11 is equal to V1 divided by I1, right? So your V1, okay, so your V1 here is equivalent to 2 ohm plus 4 ohms in series, okay, but these two resistors are in parallel with your 6 ohm resistor here and in parallel with your 1 ohm resistor here. Sorry, your 2 ohms, okay, plus with your 4 ohms, okay, are in parallel with your 6 ohms, okay, and then they will become in series with 1 ohm resistor. Okay, so what you have here is, okay, this 4 plus 2, okay, resistor are in parallel with your 6 ohm, but in series with your 1 ohm resistor. Okay, so this total of your Z here is equivalent to 4 ohm. Okay, but remember that your I2 is equal to 0. Okay, so what you have is, here is, okay, you can label, okay, with any current, okay, so here I label with I0, okay, the current that flowing through your 4 ohm resistor and 2 ohm resistor here, okay, so your I0, okay, is equivalent to, okay, 1 over 2I1. Okay, your I0 here you can use the current divider, so which means your 6 ohm, okay, divided by 6 plus 6, right? Because this is 6 ohm, this is 6 ohm, okay, so means your 6 divided by 12, okay, times with your I1 using the current divider rules, okay, and then we know that your V2, okay, V2 here is equivalent to 2 times your I0, okay, and then you substitute your I0, okay, with half of I1, okay, you put your I0 here, okay, and then you will get your V2 is equivalent to I1, okay, so from here you can get your Z21, okay, which is equivalent to V2 divided by I1 is equivalent to 1 ohm, okay, and then we go to, okay, for your second step, okay, so to obtain your Z12 and Z22, thus you, okay, give the voltage, okay, V2, okay, at your I2 and this current, okay, I2 at your output terminal, okay, by, okay, open circuit, okay, your I2, sorry, your input terminal or your I1 is becomes 0. Okay, so now here from Okay, so from your circuit here, okay, your original circuit here, okay, so when you put your I1 equal to 0, okay, so this, okay, 1 ohm resistor are also equal to 0 since your I1 is equal to 0. Okay, so you means your V2 here, okay, are not considering this I1, sorry, 1 ohm resistor because your I1 is equal to 0. Okay, so your Z22, okay, is equivalent to, okay, this 2 ohm resistor, okay, which parallel with, because this one is 0, right? Okay, we are not consider. So your Z total, okay, for your Z22, okay, is equivalent to 2 ohm in parallel with your 4 plus 6 ohm resistor here. Okay, 2 ohms, okay, in parallel with your 4 plus 6 ohm resistor here. So which give you, okay, your Z22, okay, which accumulate to 1.667 ohm. Okay, and then from here also, okay, from this circuit, okay, we can see your V1 is equivalent to 6 times I naught prime. Okay, remember that your I1 is equal to 0. Okay, so your V1 will become here. Okay, we go here. Okay, then your V1 is equal to 6 times I naught prime. Okay, and then we know from here your I naught prime is equivalent to, okay, using the voltage divider rules, okay, is equivalent to 2 divided by, okay, 2 plus 6 plus 2 plus 4 plus 6. Okay, so which give you, okay, 2 divided by 12. I 2. Okay, using the, to get your I naught prime here, using the voltage divider, sorry, the current divider rules, okay, you take the opposite, okay, resistor, right? The opposite resistor is 2 ohm, okay, divided by the total resistor here is 2 plus 10, okay, times with your current source here is your I2, okay, so which give you 1 over 6 I2. I naught prime is equivalent to 1 over 6 I2. Okay, and then you substitute, okay, here into the V1 equal to 6 I naught prime will give you, okay, your V1 is equivalent to I2. Okay, so from here also, okay, you can have your Z12 which equivalent to V1 divided by I2. Okay, that give you Z12 is equivalent to 1 ohm. Okay, okay, and then you substitute, okay, all the Z matrix, okay, or the Z values, okay, into a Z metric form. Okay, so you will have, okay, Z11 is equal to 4, okay, Z12 is 1 ohm, okay, Z21 is 1 ohms, and Z22 is 1.667 ohms. Okay. Okay, class, we go to example 3. Okay, so now class, okay, we look on our example 3. Okay, so from here, okay, the question give you, okay, the Z11, Z12, Z21, and Z22, okay, and also the input impedance, okay, and with your voltage voltage input, okay, which equivalent to 2 with 30 degree angle both, okay. So you have to calculate I1 and I2, okay, from all this information. Okay, so we know that this, okay, the first terminal is your input terminals and the second terminals is will be your output terminals. Okay, by using this general equation, okay, the solution, okay, we use, okay, the general equation, okay, for your Z impedance parameter, okay, which is V1 is equal to Z11 I1 plus Z12 I2 Okay, and V2 is equivalent to Z21 I1, okay, plus Z22 I2. Okay, so you substitute, okay, all the given, okay, Z11, Z12 until Z22, okay, into this general formula. Okay, so you will have, okay, V1 is equal to 6I1 minus J4I2, and your V2 is minus J4I1 plus 8I2. Okay, and also don't forget, okay, your V2 here, okay, your output voltage, okay, is equal to 0. Okay, and then your input voltage is 2 with 30-degree angles, okay, which equivalent to okay, V1, okay, plus with your 2I1, okay, here. Okay, so 2 with 30-degree angle, your Vs is equal to V1 plus with 2I1, okay, and then so from here, okay, you rearrange, okay, this input terminals, okay, equation, then you will get your V1 is equal to 30-degree minus 2I1, okay, and then you substitute, okay, this equation 1, okay, okay, you substitute this equation 1 into with your input or your V1, okay, so your V1, right, your V1 is equal to 30-degree minus 2I1. Okay, so you substitute your V1, okay, in your first equation, okay, and then we give you, okay, 30-degree, okay, which equivalent to 8I1, okay, minus J4I2, okay, and then you substitute your V2, okay, from your second equation, you substitute your V2 which equal to 0, okay, into your second equation, okay, we give you 0 is equivalent to minus J4I1 plus 8I2, okay. So from here also we can have your I1 is equivalent to minus J2I2. So you have your third equation and your fourth equation here. Okay, so from third and fourth equation, okay, right? So you substitute your third equation into your fourth equation. Okay, so you substitute your third into your fourth. So you substitute your I1 is equal to minus J2I2 into, okay, into your fourth equation here. So finally you will get, okay, your 2 with 30-degree angle is equivalent to minus J16I2 minus J4I2, which give you, okay, your 2 with 30-degree angles, okay, equivalent to minus J20I2. Okay, so from this, okay, equation, okay, from this substitution, okay, so you can solve, okay, in order to get your I2 value. So your I2 will give you, okay, or will give you, okay, so this equation, okay, we give I2 is equivalent to 0.1 with 120-degree, okay, which also, okay, equivalent to 0.1, okay, with minus 60-degree ampere. Okay, so now, okay, you have to solve your I1. Okay, so you just substitute your I1, okay, which equivalent to, okay, J2I2, okay, from your third equation here. Okay, so your I1, okay, is equivalent to, okay, by substitute your what you obtain, okay, from your I2, okay, that is equivalent to 0.1 with 120-degree. So this value will give you your I1, okay, which equal to, okay, 0.2, okay, with 210-degree, okay, or 0.2 with 30-degree ampere. Okay, so now you get your, okay, I1 and I2.